Welcome to Astronomy Daily, your go-to source for the latest developments in space exploration and astronomical discoveries. I'm Anna, and I'm here with my co-host Avery to bring you today's most exciting space news, from cargo deliveries to the International Space Station to mysterious exoplanets and upcoming eclipses. We've got a fantastic lineup of stories that showcase just how dynamic and fascinating our universe continues to be.
That's right, Anna. We're starting today with an update and some fantastic news from the International Space Station, where a brand new type of cargo spacecraft has finally arrived. Northrop Grumman's debut Cygnus XL freighter successfully reached the ISS on September 18th, marking a significant milestone in commercial space transportation. This wasn't just any ordinary delivery, it was the first mission of their new jumbo-sized cargo vessel, and it went remarkably well, despite a small hiccup along the way. What makes this particularly exciting is that this represents a major evolution in Northrop Grumman's capabilities. The original Cygnus spacecraft has been reliably servicing the ISS since 2013, but this new XL Ariane is a game changer with enhanced capacity and improved systems.
The arrival was quite the spectacle. NASA astronaut Johnny Kim used the station's Canadarm2 robotic arm to grapple the Cygnus spacecraft at exactly 7:24 a.m. Eastern Time, while the station was passing 260 miles above the Democratic Republic of Congo. There was actually a one-day delay due to some thruster issues, but the team worked through those challenges beautifully. What makes this mission so special is the spacecraft's enhanced capacity. This new Cygnus XL can carry approximately 11,000 pounds of cargo, compared to the previous model's 8,500 pounds. That's a substantial increase in delivery capability. The technical improvements include an enlarged service module with better solar array efficiency and upgraded thrusters for improved maneuverability, making this a significant upgrade over previous Cygnus missions.
And the timing couldn't be better. This is actually the first Cygnus delivery in over a year, so the crew was probably pretty excited to receive their supplies. The spacecraft launched on September 14th aboard a SpaceX Falcon 9 rocket from Cape Canaveral, and it's been named the SS William Willie McCool in honor of the Columbia crew member. The cargo manifest is particularly interesting from a scientific perspective. They're carrying materials for semiconductor crystal experiments, equipment for cryogenic fuel tank improvements, a UV light system for microbial control, and supplies for pharmaceutical crystal production research. The spacecraft is scheduled to remain docked until March 2026, giving researchers plenty of time to conduct their experiments.
Speaking of celestial events, let's shift our focus from human-made spacecraft to a natural astronomical phenomenon that's happening this weekend. A partial solar eclipse is set to occur on Sunday and Monday, September 21st and 22nd, though unfortunately, most of our listeners won't be able to see it directly. The eclipse will be visible from eastern Australia, New Zealand, and Antarctica, with the moon's shadow passing about 250 miles over the South Pole. The entire event will last 4 hours and 24 minutes, making it a relatively lengthy eclipse experience for those in the viewing zone.
The eclipse coverage varies significantly depending on location. Sydney will only see about 2% of the sun eclipsed, while Hobart in Tasmania gets a slightly better view at 4%. The real winner is McMurdo Station in Antarctica, where observers will witness 68% of the sun being blocked by the moon. But here's the most interesting viewing location. Southern New Zealand will experience what astronomers are calling a shark fin eclipse at sunrise, with about 20% coverage. It's fascinating how the geometry works out differently for each location. This eclipse is actually number 7 in a series of 71 eclipses called Saros Series 154.
For those already planning ahead, the next total solar eclipse will occur on August 12, 2026, crossing Iceland and northern Spain. For scientists at McMurdo Station, this eclipse provides valuable research opportunities to study how partial solar blocking affects atmospheric conditions in one of Earth's most extreme environments.
Now, let's talk about a technology demonstration that's been quietly making history in deep space. NASA's Deep Space Optical Communications experiment aboard this Psyche spacecraft has just concluded after nearly 2 years of operation, and the results have exceeded all expectations. This laser communication system has been beaming data back to Earth from incredible distances, proving that high-speed communications across the solar system are not just possible, but practical. The mission just completed its 65th and final pass, transmitting laser signals from 218 million miles away. That's comparable to the distance between Earth and Mars at certain points in their orbits.
The performance numbers are absolutely staggering. Back in December 2023, when Psyche was 19 million miles from Earth, the system successfully streamed ultra-high-definition video at 267 megabits per second. Think about that for a moment. That's faster than many home internet connections, but the data was traveling across millions of miles of empty space using nothing but focused laser light. The system set its distance record in December 2024, successfully downlinking data from 307 million miles away. Over the entire mission duration, they received a total of 13.6 terabits of data. The ground-based infrastructure is equally impressive. They use a 3-kilowatt uplink laser at JPL's Table Mountain facility and receive the signals using the 200-inch telescope at Palomar Observatory. This technology could revolutionize communications for future Mars missions and deep space exploration. NASA is already planning to implement this technology on upcoming Mars missions, potentially enabling high-definition video calls with Earth instead of the delayed, low-quality communications we're used to today.
Let's venture beyond our solar system now to discuss a fascinating mystery involving exoplanets. Astronomers have launched a new program called Atreides to study what they call the Neptunian Desert, a puzzling absence of planets about 20 times Earth's mass that orbit very close to their stars. You'd expect to find planets of this size in close orbits, but they're surprisingly rare, and scientists want to understand why. The first system they're studying is called TOI 421, located 224 light-years away, and it's already providing some intriguing clues about planetary formation and evolution.
TOI 421 is particularly interesting because it has 2 planets with misaligned orbits, which suggests their evolution was quite chaotic. TOI 421b has about 7 times Earth's mass and orbits at just 6% of the Earth-Sun distance. That's incredibly close to its star. TOI 421c is even more massive at 14 times Earth's mass and orbits at 12% of the Earth-Sun distance. The fact that their orbits are misaligned is telling astronomers a story about violent planetary migration. Instead of gently spiraling inward over millions of years, these planets likely experience what scientists call high eccentricity migration, essentially being flung around by gravitational interactions before settling into their current orbits. Understanding this process could help explain why hot Neptune-sized planets are so rare, and give us insights into how planetary systems form and evolve. The Atreides program uses advanced telescopes and space-based observations to measure not just planetary size and mass, but also atmospheric composition and orbital dynamics with unprecedented precision, helping astronomers understand the complex gravitational processes that shape these systems over millions of years.
For our final story today, let's journey to the outer reaches of our own solar system, where the James Webb Space Telescope has made a remarkable discovery. Webb has detected methane gas on Makemake, a distant dwarf planet, making it only the second trans-Neptunian object after Pluto, where gas has been confirmed. Makemake is about 890 miles across, roughly 2/3 the size of Pluto, and this detection suggests it's far more dynamic than previously thought. The methane was identified through what scientists call solar excited fluorescence, where sunlight causes the methane molecules to emit detectable signals.
This discovery opens up fascinating possibilities about what's happening on Makemake's surface. The methane could indicate the presence of a thin atmosphere, or it might suggest active sublimation processes where ice turns directly into gas, or even cryovolcanic activity, essentially ice volcanoes. If Makemake does have an atmosphere, it would be incredibly tenuous, with temperatures around 40 Kelvin, that's negative 233 degrees Celsius, and atmospheric pressure about 100 billion times weaker than Earth's, making it 1,000,000 times more tenuous than even Pluto's thin atmosphere. But the very fact that we can detect this gas shows that Makemake isn't just an inactive chunk of rock and ice floating in the outer solar system. It's a dynamic world with ongoing geological or atmospheric processes. This challenges our understanding of what makes a world active in the outer solar system, and scientists are planning follow-up observations to determine whether the methane represents seasonal effects or more fundamental geological activity.
You know, Avery, when we look at all these stories together, what really strikes me is how they represent different scales of human achievement and cosmic discovery. We've got practical successes like cargo delivery to the ISS, incredible technological leaps like laser communications that will enable future exploration, and we're pushing the boundaries of knowledge by studying distant worlds and exoplanets that expand our understanding of planetary formation.
Absolutely, Anna. And what I find particularly exciting is how these technologies and discoveries build on each other. The same infrared detection capabilities that let us find methane on Makemake are helping us characterize exoplanet atmospheres. The laser communication systems being proven on the Psyche mission will eventually enable high bandwidth data transmission from Mars. Even the enhanced cargo capabilities of the Cygnus XL are enabling the kinds of experiments that will prepare us for establishing permanent research stations throughout the solar system.
And that wraps up today's episode of Astronomy Daily. From the successful arrival of the new Cygnus XL cargo spacecraft at the International Space Station to the mysterious dynamics of distant dwarf planets, it's been another incredible day in space exploration and astronomical discovery news.
Thanks for joining us today, everyone. I'm Avery, along with Anna, reminding you to keep looking up and stay curious about the amazing universe around us. We'll be back tomorrow with more exciting space news and discoveries. Until then, clear skies.